Hello friends, myself R.D. Mahajan presenting my video on inverse Laplace transform technique partial fraction method. Case number 3, when factors are real and quadratic. Let us solve the problem. Find inverse Laplace of 1 upon s minus 1 into s square plus 1. First we check whether it is proper fraction or not. The degree of numerator term is 0 here and the degree of denominator term is 3. 0 is less than 3, therefore it is proper fraction. And then if we see the factors, the first factor is real and distinct. The second one is a quadratic factor, and as the factor is quadratic, we have to use this partial fraction method. What is the technique? I will explain with the help of this example. That given term 1 upon s minus 1 and s square plus 1 we can rewrite as, for this real and distinct factor it is a upon s minus 1, and for this quadratic a way to write the factor a partial fraction is b into s plus c and divided by that factor s square plus 1. Therefore, this is the way in which we can make the partial fraction, and we call this as equation 1. And then finding LCM. LCM is s minus 1 into s square plus 1. Dividing by s minus 1, remaining is s square plus 1. And therefore, we get 1 is equal to a into that s square plus 1. And dividing by s square plus 1, this get cancelled, remaining is s minus 1. Therefore, bs plus c into s minus 1. Then, multiplying term by term inside, we get a into s square plus a into 1 means a, bs into s means it is bs square minus bs plus cs and minus c. Then collecting the terms of s square in one first bracket, therefore there are two terms of s square, therefore remaining terms are a plus b into s square. Then collecting the terms of s, there are two terms, therefore it is c minus b into s, and then constant terms are 2 a and c, therefore it is plus a minus c and equals to 1. Therefore, comparing two sides, the coefficient of s square is a plus b and no term of s square on the left hand side, therefore equal to 0. Then c minus b, again no term of, therefore it is also 0. Then solving these two equations, we get minus b plus b get cancelled, a plus c is equals to 0. And last constant term is a minus c and it is equals to 1. Again solving these two equations, plus c minus c get cancelled, a plus a we get 2a and that is equals to 1, and therefore we get the value of a as 1 by 2, and therefore from this we get b is equals to minus a plus b equal to 0 means b equal to minus a, and substituting the value of a as 1 by 2, we get the value of b as minus 1 by 2, and c is equals to minus a, and therefore we get c as minus 1 by 2. A as minus 1 by 2, b as a as 1 by 2, b and c as minus 1 by 2. Therefore, substituting that values in equation 1, substituting values of a, b and C, we get A as 1 by 2 divided by S minus 1, B as minus 1 by 2 into S, plus C as minus 1 by 2 divided by S square plus 1. And then taking inverse Laplace on both sides, and therefore we get inverse Laplace of 1 upon S minus 1 and into S square plus 1, and that is equals to taking individual inverse, therefore 1 by 2 constant term outside, inverse Laplace of 1 upon S minus 1. From this two term I can take minus 1 by 2 common, and inverse of this S upon S square plus 1, separately dividing by S square plus 1, and plus 1 upon inverse of 1 upon S square plus 1. We get from this two term I can take 1 by 2 common throughout, and therefore it is 1 by 2 into inverse of 1 upon S minus 1 is e raised to plus at, A is here 1, therefore it is e raised to t, minus inverse of S upon S square plus 1, standard result is cos t, and inverse of 1 upon S square plus 1, as per standard result it is 1 by A, 1 by 1 is 1, and sin t. As a required answer. Therefore, in this video, I have discussed very simple example how to obtain the partial fraction method, or how to find the inverse by partial fraction method when factors are quadratic like this. Here it is a quadratic factor. A very simple example. In my next video, I will discuss one more example of inverse Laplace transform when factors are quadratic. Therefore, if you like my video, please share it, as well as subscribe to my channel, and to receive the notification for my new videos, press the bell icon. Thank you. Thanks for watching.